So, what we're going to do today is do the same thing that we were doing yesterday, except we're just going to add the wholes to it that I talked about a lot yesterday, but you just really didn't see it like in play. You didn't see it like the way it's supposed to be. Okay, so on your notes, we're not going to do example 2 because example 2 doesn't have a whole. So I don't want to waste time going over one that doesn't have a whole. Okay, so then we go to example 3. So I don't know if you remember yesterday or not, but I recommend that you find the horizontal asymptotes first. Okay, so what do you find first? Horizontal asymptotes. So Kim, get off your phone. Lewis, take the earbuds out of your ears. Anybody else with earbuds in your ears, take them out. Okay, Isaiah, take the hat off. Okay, so let's go find the horizontal asymptotes first. All right, so down here, so we're at number 3 on your example for today's notes. Okay, how do you find the horizontal asymptotes? What do you look at? The degree of both the numerator and denominator. See, it says it right here, okay, right here. So we go back up here. The degrees are 2 and 2. So that's equal, right? Okay, well, when the degrees are equal, what do we do? We look at the front, the coefficients in the front. So we have we have a 2 and a 1, okay? We have a 2 and a 1. So what is the horizontal asymptote? 2, okay? 2 over 1, 2. So that was easy. The horizontal asymptote is 2. So it is a little different, and I'll kind of look at one here in a minute with you maybe when the horizontal asymptotes or when the degrees are different, okay? Now, let's go back and factor it. So on that little strip that I gave you, at the very top it says factor first. Well, ignore that. Don't factor it first. Do the horizontal asymptote first, then go back and factor, okay? So does this numerator factor? Yes, they'll both divide by 2. Okay, I'm going to actually factor over here. They'll both divide by 2, and then we get x squared minus what? 1. Okay, on the denominator, how do they factor? What multiplies to a negative 3 that adds to a negative 2? A 3 and a 1, yeah, I mean, there's only one factor of 3 and 1. You just got to figure out the signs. Okay, so what is it going to be? A negative 3 and a positive 1. But this numerator right here can factor a little more, right? So it's difference of 2 squares. Okay, x plus 1, x minus 1. And then we have x minus 3, and we have x plus 1 there. So we kind of have a big old mess. Okay, but notice how something cancels out here. So gently, don't do it big time, just kind of gently cancel those out. Okay? So that's where our whole is. So what I'm going to do here is kind of rewrite it. I'm going to write it without the whole. Okay? And then the whole part is right here. Whoops, minus 1 and x minus 1. So I have it all written here. I just kind of separated it. Okay? We have the whole and the non-whole. Yep, I should have a plus 1 here. Thank you. Oh, wait, nope, I did it wrong. Hang on. Okay, so this is x minus 1, and this is plus, and this is plus. Okay. So now, how do we find the whole? Okay, so to find the x of the whole, okay, it's super easy. You take the canceled part, okay, the canceled part, which is x plus 1, and you tell me what x is. You set that equal to 0. So what is x? Negative 1. We just practiced that a minute ago, right? Okay. Then, okay, so the x of the whole is a negative 1. It's a point on the graph, so it has to have an x and a y. Okay, to find the y of the whole, you take this x and you plug it into the non-whole. Now, I don't know if you want to call it non-whole or the non-canceled out part, right? Okay? Okay, because non-whole, that's probably not even really a word, something I made up. But you get my point, right? Okay. Okay, so we plug -1 into the non-whole part. So 2 times -1 minus 1 over -1 minus 3. I plugged the x in right here and right here. Okay, and then you just work it out. Sometimes you can do it in your head. This one is kind of one you probably can't do in your head. Okay, so 2 times -2 over -4. Okay, what's 2 times -2? -4 over -4 equals 1. Okay, so we have a hole at 1, or at -1, 1. All that just for a hole. But I did say a minute ago, some of them aren't that complicated. You can kind of do them in your head sometimes. But just be careful when you do stuff in your head that you don't make a careless mistake. A lot of them don't have that 2 in the front and like that, and so you can do it faster just by scratching it out real fast, you know, on the thing. So I'm just going to draw a little sketch over here on the side board. Okay, it's not required, but I just want y'all to see how this all kind of comes into play. So right now, all we have is we have the horizontal asymptote, which was at what, 2? Wasn't it at 2? Okay, so there's my horizontal asymptote going there. We have a hole at -1, 1. Okay? Okay, now we've taken care of the hole. Now, the hole is just that. It's a hole, so it's not there. So we don't use this. We use this from now on, okay? The only thing we needed this hole for right here was to find the x of the hole. Now we're done with it. So don't use the canceled out part anymore, okay? Got that? And it even says so on that little strip of paper. It says, don't use the canceled part. You know, it says that all the way down, okay? Okay, so let's just do the vertical asymptote, just like yesterday. How do you find the vertical asymptote? Set the denominator equal to 0. It says that on that little strip of paper you have. So you go back up here, you just use this right here, x minus 3, okay? So x minus 3 equals 0. So what is x? 3, okay? So now over here on my little sketch here, huh? No, because the 2 in the front was in the numerator. Okay. In a minute, though, we will when we do the x-intercept. So there's my vertical asymptote at 3. Okay. Okay, we've already done the horizontal asymptote. Okay, the x-intercept, you put the numerator equal to 0. The numerator is what's on top. So we have 2 and we have x minus 1. Remember, don't use the canceled out part. It's a hole. It's not there. Okay? You set that equal to 0. So you say 2 equals 0. And you say x minus 1 equals 0. Okay? But does 2 equal 0? No. So you get to mark that out. So what is x here? 1. Okay? So we have an x-intercept at 1. Sometimes, guys, you might get 2. Well, no, you're not going to get 2. Sometimes you might get 2 x-intercepts. Sometimes you might get 2 vertical asymptotes. Sometimes you might get 2 y-intercepts. There's just once in a blue moon that happens, and I think it happens on your paper too. Okay, the y-intercept, it says solve for f of 0. Okay, so your x is 0. Plug x into the non-canceled. And I think it says that on your notes and your paper. So again, we're going to take this non-canceled part to x minus 1, x minus 3. Okay, where are we? Let's see, 2, here we go. 2, x minus 1, x minus 3. And we're going to put a 0 in every time there's an x. And once again, some of these are easier to do than others. This 2 is just kind of messing us up a little bit. Okay? So we get 2 times negative 1 over negative 3, right? Okay? And so 2 times negative 1 is negative 2 over negative 3, which is positive 2/3. I ran out of room. Okay? So our y-intercept is at 2/3. If you didn't have a 2 there, guys, it's super easy. Like over here, let's say I had 0 minus, well, let's say I had x minus 5 over x plus 7, right? So you're going to plug a 0 in here. Are y'all watching? Okay, so really, those are zeros. You just cover it up. Oh, negative 5/7, right? But over here, like I say, that 2 messed it up. We really couldn't do it in our head like that. Okay? Okay. Now, last is the domain and range. Okay, we're not going to do it that way. We're going to do it my way because I like it. It's easier. The domain is going to be every single x in the whole wide world, except it's not the vertical asymptote. It's not the x of the whole. Yesterday, we didn't have any wholes, so we didn't have to do that part. Okay, then the range is all real numbers. It's not the horizontal asymptote, and it's not the y of the whole. Okay? So what's my vertical asymptote? What's the vertical asymptote? 3. So it's not 3 because remember the definition of asymptotes. Nothing touches them. So no part of the graph is on the vertical asymptote. So that's why we have to exclude that, 3. Okay? And then the x of the whole is that. It's just the whole. There's nothing there. So our graph isn't there. So what's the x of the whole? Go back up here and you look. Okay? It's a negative 1. Okay? What's the horizontal asymptote? Remember, nothing's going to touch this horizontal asymptote. So none of my range, none of my graph can be on this vertical asymptote. What is it? 2/3, right? Remember, we just... Oh, no. Y'all are right. Y'all are right. I was thinking of the y-intercept. Okay. Come on. Okay. It's a 2. Yes, 2. I have it right there. Okay, and then what's the y of the whole? 1. Okay? So, don't come ask me how to do something until you've looked in your notes over here in this second column, or you've looked at your little strip thingy, okay? And don't lose that little strip thingy because I don't have enough of them to give you another one. Possibly, okay? Okay, so now look at your homework, your stapled packet. Okay, look at your stapled packet. We're going to do problem, we're going to do problem 9 together. Okay, so Noah, you ready? Ready to do number 9? You have your homework out? Okay. Okay, so what's the first thing we do? No. Horizontal asymptote. Okay, horizontal asymptote. How do you find the horizontal asymptote? What do you look at? You look at the degrees. Okay, this degree is a 1, this degree is a 3. You look at the degrees, the first ones. Okay, when the numerator degree, I probably shouldn't write there because we're going to need that later to factor. Okay, when the numerator degree is smaller than the denominator degree, We had a what, a 1 and a 2? Then, oh, a 3. Okay, then what is the horizontal asymptote? You have it written in your notes, okay? What is it? Y equals 0, okay? Oh, I didn't finish this over here in a minute. I'll finish that in a minute. Okay. Then, now we back up and we factor it. Oh, I didn't mean to write that there because that's problem 10. Numerator is less than denominator. 1 is less than 3. So be careful. That's an actual problem. That's not your note place like I did. But that's why you're doing it in pencil, right? Okay, so now we back up and let's see if we have a whole. We have to factor it first to see if we have a whole. Okay, Noah, sit up. Sit up. Okay. Now, does the top factor, does the numerator factor? No. Okay. Does the denominator factor? Yes. Okay. They all divide by 3. Yes, ma'am. Yes. Bye-bye. Draylin, they want you down in the counselor's office. Okay. Now, these all divide by x, right? So we bring out an x, and then we get x squared minus x minus 2. But what do we have to do now? Factor again. Okay, so hopefully you left yourself enough room. Okay, so x, what multiplies to 2? What are the multiples of 2? Okay, 2 and 1. So x minus 2, x plus 1. Okay, does something factor? Yes. Okay, these x plus 1s do. So when I get rid of those x plus 1s, this is what's left on the bottom, right? Well, what do we write in the numerator on the top? A 1. Don't leave that blank. So you are going to use this, okay, after we figure out what the whole is. Okay? How do we figure out what the x of the whole is? Okay? You take the canceled part, and what is it going to be? -1. To figure out the y of the whole, what do you do now? You plug it in. You plug this -1 into the non-canceled out part. Okay, so you have 1 over -1 times -1 minus 2. Okay, what's -1 minus 2? Okay, we're subtracting, like, so it'll be a -3. Now we're multiplying, so it'll be a +3, right? Okay? Yeah, here we're not multiplying. We're just a -1 minus 2 is a -3. Then we're multiplying here and we get a +3.
But if it was like -1 and then a +2.
It'd be a, well, no, a -1. You're still just adding here. See, it says to subtract, where you're subtracting. Okay, so we have our whole. We found our whole, didn't we? Okay, now for the vertical asymptote, what do we do? You set your denominator equal to 0. Y'all better start memorizing some of this. Okay, you set your denominator equal to 0. Miranda, you getting this written down? Okay, so what's our denominator? What's our denominator? We have an x, and we have an x minus 2. So we have to say x equals 0, and we have to say x minus 2 equals 0. So in this case, we have 2 vertical asymptotes. We have x equals 0, and the other one is x equals 2. So remember a minute ago I said sometimes you get 2 of things. This is a case where we have 2 vertical asymptotes. Okay, because we set the denominator for vertical asymptote, you set your denominator equal to 0. So x equals 0 and x minus 2 equals 0. And we have two of them. Okay, now the x-intercept. How do you find the x-intercept? Numerator equals 0. Good. Okay, in the numerator we have a what? A 1. 1 equals 0. Does 1 equal 0? No, that's crazy. So we don't have an x-intercept. Okay? Okay. Y-intercept. How do you find the y-intercept? You plug a 0 in for x. Plug a 0 in for x. Use the non-canceled one. So you have that 1, and then that x minus 2. Is that what it is? Okay. So you have a 1, a 0 times 0 minus 2. 1 times 0. I mean, do I need to keep going here? Because you're going to have a 0 on the bottom, aren't you? You can't have a 0 on the bottom. You can't divide by 0. You can have a 0 in the numerator, but not in the denominator. So this is undefined. You also don't have a y-intercept. Okay? So we're basically done now except for naming the domain and range. Okay? So again, the domain is all real numbers. It's not the vertical asymptote. It's not the x of the whole. The range is all real numbers. It's not the horizontal asymptote. It's not the y of the whole. Okay? Okay, so what is our vertical asymptote? Okay, we have 2 of them, don't we? So it's not a 2 and it's not a 0. What's the x of the whole? Okay, so you just look right here, guys. You're not having to do any math. You're just going back and looking. Okay, the x of the whole is -1. The vertical asymptotes were 0 and 2. Okay, so it's not -1. Okay, what's the horizontal asymptote? 0. Y is not 0. What's the y of the whole? 1/3. Okay? Okay, so let me turn this off.